Hey guys, here's your second example problem in the document below. This one is for parallel circuits. Like before, I want you to just look at the circuit and the problem written up here and draw it in your notebook before you get started, okay? Go ahead and do that now. Alright, so it's drawn in your notebook, right? And we can get started. The problem wants us to calculate the current in each branch. Those are these, right? Then calculate the total current through the battery. So basically they want us to get here I1, they want us to get I2, okay? And they want us to get I3. Alright, so what are those? I'll put a little question mark there. And then once we get those, we know that in a parallel circuit they join up and connect together to make IT, or the total current. So that'll be like the last thing we solve for, the total current. Alright, so if we have a 120 volt battery, right, is one piece of information they give us. We know the resistance of each resistor. R1 is 30, R2 is 60, and R3 is 90. Alright, so what do we need to do to find, let's start with I1. Let's find the current through the first branch, right? So I'm just going to label like branch 1. I'm going to do first here. And let's find I1 through that branch. So like usual, we're going to use Ohm's law. V1 equals I1 R1. And that's, I just put the ones to indicate that Ohm's law is being applied just to the first branch. Okay, so we know that the resistance in the first branch is 30 ohms. We're going to try and calculate I, so I'm just going to leave that there. And the voltage, well, what's the voltage dropped here? Well, you know, in a series circuit the voltage drops split up, but in a parallel circuit they don't. So the voltage in a parallel circuit is all equal to the voltage of the battery. Every branch, the electrons that pass through each branch pass through that branch and return right back to the battery. So they drop all 120 of their pretzels in whichever branch they go through. Okay, so you can be rest assured that your voltages will all be the same in a parallel circuit. Alright, why don't you kind of write that to the side here. Voltages all equal in a parallel circuit. Right? But the currents, are the currents equal in a parallel circuit? No, they split up, they join back up, they split up, and they join back up. So the currents are not equal in a parallel circuit. Okay, so once you get this set up, you can go ahead and divide each side by 30. Okay, 120 over 30 is, I believe that's 4 amps. And we'll do branch 2. Let's find the current in branch 2. V2 equals I2 R2. Remember, all the voltages are the same in a parallel circuit. I2 is what we're going to solve for. Okay, and R2 is 60 ohms. We could divide by 60 ohms and get our current, which ends up being 2 amps. More resistance, less current in branch 2. In branch 3, alright, we do the same thing. And the great thing about a parallel circuit is that all the voltage drops are the same, so you keep plugging in 120. Divide both sides by 90, and you'll get current 3, which is 1.5 amps when you divide 120 by 90. Okay, so those are your currents in each branch, and it really helped us to know that voltages are all equal in a parallel circuit to do that. But finally, the last thing we're going to do is we're going to figure out the total current, right? So when all three of these currents join up, simply all you do is you add them. In a parallel circuit, currents of each branch add to the total current. So this is where the total current is flowing through the battery. Alright, so IT, the total, equals I1 plus I2 plus I3. That's what we're going to do to figure out the total. So that's 4 amps is I1, right? 2 amps is I2, and 1.5 amps is I3. So your total current, 6, 7.5. So I could ask you a question later on, something like, well, if you have a 5 amp switch here, and this is like your circuit breaker over here, and all these currents are adding into the circuit breaker from a room, if you have a 5 amp switch, will it blow? Well, if the total current is greater than the rating of the switch, 7.5 is greater than 5, then that switch will blow, and you'd have to like turn one device off or another.